Hello, my name is Alejandro González Quintanilla, and today, with the help of my team, we're going to be solving the following optimization problem. So, this problem consists of the following. A worker is given a task of designing a cylindrical aluminum can to hold 750 milliliters of soup, which is also the same as 750 centimeter cube in volume. The goal is to design the can using the least amount of aluminum possible. That's a clue word. What should the radius and height of the can be to use the minimum amount of cereal? Well, in this case, first of all, we need to start writing and drawing the problem. So in this case, we're gonna draw a can. Well, of course, I'm not the best at drawing, but here is it. So we know that the values of a can consist of the radius and the height. Now, in this case, our purpose is to find the radius and also the height to be able to know which one is the best for it to have the least amount of aluminum possible. So we know that the volume of the can must be 750 centimeters square. And the to find the volume, we have a formula, which is the following. It is pi times radius to the square times height. Now, we also gonna be needing to have the formula for area because that's gonna define how much aluminum are we gonna use in this occasion. So we have that area equals to 2 times pi times radius plus 2 pi radius h, which is radius height. So in this occasion, we have this one that is the first value, this one which is the second, but it is like the formula, and the third one which is height. So now what we're gonna do is the following. These two, we're gonna combine them. As we know, 750 centimeters cube equals to this because it's the same thing. Both represent the same value. So that means that 750 equals to pi times radius to the square times height. So now what we gotta do is to combine these equations in order to make it more simple. Okay? In this occasion, what we're gonna do is trying to find h, the height, to make it more simple. How do we find height? Well, we know that 750 equals to 2 pi times radius to the square and height. So we have to isolate the h. So it will end up being like this. 750 over pi times radius to the square equals to h. Now, this is the same as this because this here represents h. So it is the same as in here. Now, we're gonna arrange the equation in the following way. We have that A, which is the area that we're gonna be using of the material, equals to, like here you can see, 2 pi times, well, 2 times pi times radius to the square plus 2 times pi radius. And then we're gonna substitute the h as in here because we already know that this is the same as h. We're gonna write the parentheses because it is multiplying. Then we write 750 over pi times radius to the square.
Hello, my name is Carlos Ramirez, and I'm going to continue explaining what my my teammate Alejandro was doing. So now, as we got this formula, we need to simplify this because now our formula depends on the one variable. As you can see, this is the only variable that it depends on. So what we need to do is to simplify this. So we only need to multiply, which will be approximately this. So now we have that this converts into this. And now we can see that what we need to do next is to make this a function. Why a function is because, as you can see, if we do a graph, a little graph in here, you know, so this is the area, and this is the radius. So we suppose that the graph will look like this, something like this. Yeah, well, it's like an example. So in all this, like in all of this, in all of this, what we need to find is the minimum. Which is the minimum? So the minimum will be around here because it's the minimum part of this function, or well, as we can see, of this graph. So now, as we have this, we need to represent it so we can like we can understand it in a better way.
Hi guys. Hi guys. Today we're gonna start doing the my part. Actually, we're gonna do just the same as we did after this exercise. Just let me. So the function right now is fr is equal to p 2 pi square root. So we're gonna go for the derivative, and there it is. Once we have it, we need to solve it and equal to 0. So it will be uh, 4 pi r minus 1000 over r to the square equal to 0. Sorry. So next we're gonna multiply everything. To solve, we need to get rid of the square. So we're gonna multiply everything by that r square. So then it'll be 4 pi r to the q minus 1000 equal to 0. We're gonna keep going and answer that linear equation. And it'll be something like 4 pi r q over 1,000, sorry, minus 1,000. So r q 1,000 over 4 pi. R it's equal to 250 over pi square root of 3 or q. And that'll be the answer. Now we have the answer. We're gonna go, just to specify, sorry, it'll be something like 4.30 centimeters. So what this tells you, I'm gonna show you that. Just give me a minute. So what does this tell you? We're gonna go for a little table so you can understand. First of all, we need to know how does it looks on the graphic. So how are we gonna supposed to know that? We need to know where is the 4.30 centimeters, because that's what we get on the answer that we just solved. So we're gonna go for the table, and we're gonna put I'm sorry, the point. So it'll be 0, 4.3 and 4.3 and infinity, and etc, etc. So what we really need to understand, what we really are noticed in the graph is that it's going down. We notice that it's negative, as we can say, because the 0 and the A and the R, it's pointing to the lowest. That'll be the minus, and that right there, it'll be the 4.3 centimeters. So the A, we can know that one is the local minimum. That'll be all for me. That's all in my part. Thank you so much.
Okay, my name is Carlos Rivas Salinas, and I'm going to continue to solving this optimization problem. Okay, so once we obtain the radius, we're gonna looking for the height by using the following formula. Okay, the formula says the height equals to the volume, which in this case is 750 over pi times radius squared. Okay, and then we are gonna substitute the r that stands for radius with the real value that is approximately 4.9, and it's equal to 750 over 76.5, and that is equal to 9.8, and we get the height. Okay, so now we need to get a conclusion. Okay, if we design the can with these values, which are the radius being 4.9 and the height being 9.8, the volume will be 750 centimeters. So the area will be as least as possible.